Hi everyone, the research that I'll be presenting is the focus of two separate wildfires that were ignited in Hilda and Empress, Alberta on the 17th of October 2017. The northern fire that you can see in this image is the Empress fire, while the southern fire is the Hilda burn. Combined, both of these fires burned a total of 69,000 acres, with 20,000 acres being native pasture land. On the day of ignitions, there was very high wind speeds, which exceeded 120 kilometers per hour, as well as a mild but persistent drought, which occurred for much of the summer. Both the drought and the wind speeds were contributing factors that led to the fires burning so much above ground biomass. These two fires led to the removal of stockpiled forage, agricultural infrastructure such as fences and barns, as well as the death of hundreds of animals and one volunteer firefighter. All of these losses left many producers at a loss of how the two fires affected their land and how to fully recover from the two devastating fires. Before I get further into my presentation, I do want to take a moment to acknowledge that I live and work on Treaty 6 territory and the homeland of the Métis. The research that I will be presenting shortly, as well as the research for my master's project, is done more broadly on Treaty 4, Treaty 6, and Treaty 7 territory and the homeland of the Métis. In making this statement, I am offering my appreciation and gratitude to the land, which has taught me about ecology, the role of fire in the prairies, and the Indigenous peoples whose knowledge I have learned from in my work. By acknowledging the land, First Nations, and Métis people, I am reaffirming my relationship to each. I would also like to take a moment to recognize all my funding agencies, as without their help, my project wouldn't be possible. The Agricultural Development Fund, from the Government of Saskatchewan, the Government of Alberta, Environment and Climate Change Canada, and lastly, the Saskatchewan Cattlemen's Association. I would also like to point out the immense help that I've received from Dr. Julin Gao, Dr. Roy Vera, and Dr. Eric Lam, my supervisor. So now on to my objectives. My first objective was to measure fire severity using remote sensing. My second objective was to measure productivity recovery using remote sensing 1 year following the wildfires. For my first objective, I used the Bare Soil Index, also known as BSI. The Bare Soil Index was designed to measure the amount of bare soil in a remotely sensed image. BSI was selected to detect fire severity because fire severity is defined as the immediate effects of a fire. Immediate effects of a fire are further defined as the amount of biomass removed and amount of bare soil exposed. For my second objective, I used the Normalized Difference Vegetation Index, also known as NDVI. The Normalized Difference Vegetation Index was designed to measure the amount of vegetation greenness in a remotely sensed image. NDVI was selected to detect the recovery of biomass because greenness can be a good indicator of productivity, especially after a fire, as there are bright green flushes of new regrowth. So now, before I can get into my results, I'm going to quickly cover my methods, as this is preliminary work. So I chose 4 Sentinel-2 images, which ranged from pre-fire during peak biomass production in the summer of 2017 to peak biomass production in the summer of 2018, with 2 images as close as possible pre-fire and post-fire to the October 2017 wildfires. From there, I chose the October imagery to create a false color composite, as you can see here on the right, that highly distinguishes between burn and unburn areas. And so for both burn areas, for the Empress and Hilda fires, I chose 2 test areas of burn and unburn, so 4 total, to be able to pull out the pixel values from my 2 spectral indices, NDVI and BSI. These pixels were then used to create figures, which you'll see in my results, as well as run preliminary statistical analyses. So now Now getting into some results. So for my first results, I'm going to be going over fire severity using BSI. And I chose to assess and compare the amounts of pre-fire bare soil exposure from my September imagery to the amounts of post-fire bare soil exposure using the October imagery. Before I get into the comparison, though, I do need to quickly go over that BSI values range from +1 to -1. Negative values indicate live vegetation cover, whereas positive values can indicate bare soil or senescent vegetation. So the more positive the value, bare soil, whereas lower positive values indicate senescent vegetation. So as you can see here on the y-axis for September 2017, both the burn and unburn groups fall from -0.1 to approximately 0.05, indicating both live and senescent or dead vegetation present within these two areas. And this is reasonable, as this is a fall image and there is still some live green vegetation as well as the dead dying off plant material. Now shifting to the October axis or the x-axis, we can see that there's a big shift or gap created between burn and unburn areas. And so our unburn areas still remain within the -0.05 to +0.05 to 0.1, depending on how specific you want to get here, indicating that unburn areas still have live and dead plant material. Yet when we shift to and look at our burn points or test areas, we can see that there was a big gap created visually as well as numerically to a shift to 0.15 to 0.25 for values. And these values indicate bare soil exposure. And from there, we can extrapolate that a high fire severity was seen. And this is because of the gap created in values from senescent vegetation to complete bare soil exposure. So now on to the recovery of biomass productivity or grassland productivity. I chose to assess and compare the amounts of greenness during peak biomass production in the July of 2017 versus the summer of 2018 using the normalized difference vegetation index, as I mentioned. Like the bare soil index, the normalized vegetation index does range from negative to +1, where positive values indicate green vegetation with negative values indicating dead vegetation or bare soil. As you can see here by this figure, it is a nearly positive linear relationship. And as we get here into the more positive values, we can see that the pre-fire NDVI values for the burned areas for the summer of 2017 lead to a higher post-burn NDVI value for the summer of 2018. The opposite is seen for the lower the NDVI value. So the lower NDVI value for the summer of 2017, the lower the NDVI value for the summer of 2018. Overall, it can be seen that the higher productive sites before the fire allowed for higher productive sites or greenness post-fire. To finish with my conclusion, for my first objective of measuring fire severity using remote sensing, as we saw in that figure there was a change from slightly positive to highly positive BSI values, which indicated a large amount of biomass was removed following the fires, thus exposing large amounts of soil, which in the end suggested a high fire severity was caused by both the Hilda and Empress fires. Now for my second objective, to measure productivity recovery using remote sensing 1 year following the fires, we saw that the higher the pre-fire NDVI values, the higher the post-fire NDVI values. So better pre-fire condition ensured a better recovery trajectory following the fires. Before I end off here, I do want to mention a little bit of my further work that I will be continuing with. And so, as both fire severity and recovery results are preliminary, over the next while I plan to work on the entirety of the 2 burns to assess if the same trends follow, which I do expect them to. From there, I aim to assess further into the recovery period into the summer of 2021. I also want to assess how biomass recovery is a function of fire severity. So could high fire severity lead to a higher or lower amount of biomass production following the fires? Overall, I'm expecting similar trends as the ones I saw for the NDVI results, as it has been hypothesized and proven many times that pre-fire conditions is a determinant of how native prairie ecosystems recover. Lastly, before I end, thank you for taking your time to listen to my presentation, and if you do have any questions, please reach out to me at seg267@usask.ca. I'll also be available for any questions as of today, but please let me know if you do have any other questions. Thank you so much. Bye-bye.